Hey AP Stats, it's Mr. Luneski. We're going to talk today about Chapter 21, which is about Type 1 and Type 2 errors. So this picture here just kind of does a very quick summary of what a Type 1 and a Type 2 error is. Type 1 error is sometimes referred to as a false positive, and a Type 2 error is sometimes referred to as a false negative. False positive meaning here of saying that something is happening when it isn't, and a false negative is saying that something is not happening when in fact it is. So we're going to kind of just go through the notes real quick here and kind of catch you up if you were absent. So last class we talked a little bit about p-values, so I want to just remind you what a p-value is. P-value was a probability that an event would sort of reoccur. I described it as picking your p-hat out of a pile of p-hats. The idea was that based on our p-value, we would then make some sort of claim about the null hypothesis. Last class we talked about how there was no such thing as a magical p-value, but we actually have sort of a threshold that's called an alpha level. This is something that the researcher typically sets before the study begins. A good researcher should set it before the study begins. And then that kind of sets the tone for, okay, well, my alpha level is going to be 5%. And so then if any p-value comes along that's less than 5%, then you reject the null. So sometimes that alpha level is referred to as a significance level. Again, we have to set that value before you collect any data. So if you ever run your own tests, alpha level needs to be set beforehand, not after the fact. And then like we talked about, if your p-value falls below that alpha level, that means that we have statistically significant results and we would reject the null. So some common alpha levels that you're going to see in this class are 10%, 5%, 1%. Typically, we're going to use 5%. So if a problem doesn't specify, then you can just assume that it's going to be 5%. One way to calculate the alpha level is if they give you a confidence level and say, use a 95% confidence level, you would do 1 minus the confidence level and then divide that by 2, and that would give you the alpha level. So we kind of talked a little bit about confidence intervals in Chapter 19. So if we have some sort of p-value with the hypothesized proportion, if it falls within a confidence interval, we would fail to reject the null. If it falls outside of the confidence interval, we would reject the null. So that's a little bit about alpha levels. So like I said, with most of the notes here today, what most of the notes here today are about our Type 1 and Type 2 errors. So we essentially say that if we reject the null hypothesis when the null is actually true, that's called a Type 1 error. Alpha represents the probability of making a Type 1 error. If we fail to reject the null hypothesis when the null is actually false, that's a Type 2 error. That is sometimes referred to as beta. In class, I showed a very corny video of The Boy Who Cried Wolf. If you don't know the story of The Boy Who Cried Wolf, there's a shepherd boy, and he goes screaming into the town, and he's like, "Oh, there's a wolf, there's a wolf." But he's just playing a prank, and there's actually no wolf, and everyone in town's freaking out because they think there's a wolf. And then he does it again, and they're like, "Ah, you rascal, there's no wolf." And then an actual wolf comes and starts terrorizing the sheep, and the shepherd boy is like, "Ah, there's a wolf, there's a wolf." And then no one believes him because he's a liar. The Boy Who Cried Wolf, that story essentially is a Type 1 error and then a Type 2 error. The null hypothesis would be that there is no wolf, and so at the beginning the boy is claiming there is a wolf, when in fact there was no wolf. That's a Type 1 error. And then at the end, when there actually is a wolf, the people believe that there is no wolf, and so that's a Type 2 error. There's something we'll talk more about in a minute here called the power. The power is the probability of rejecting the null given that it is false. This is essentially what we want. We want to reject a null that is false. I'm going to use the word except. I don't want to, but I'm going to. If you use essentially when we reject the null because it's false, that essentially means that we're accepting the alternate, which is essentially what we want. But again, we don't say accept. So to increase the power of a problem, you can use a larger alpha level, or you can increase the number of trials that something has occurred. So the crazy thing about a type 1 and a type 2 error is that you can't really know for certain if you're making one of those errors. You kind of just have to be aware of that situation. If you think to any of the activities that we did in class, like the globe toss, some of you rejected the null and said that the globe was not accurate, but some of you failed to reject and said that the globe was accurate. Doesn't mean that any of you were wrong, it just means that you had a unique sample. That's all. So there's a lot going on here. So up here, this is just kind of a friendly reminder that a type 1 error can only be made if you reject the null hypothesis. The probability of a type 1 error given that the null is true is our alpha level. Alpha and beta link together, so as alpha decreases, beta increases, or if alpha increases, beta decreases. So they kind of play against each other, so to speak. This little chart here kind of sums up everything that we can do with the null. If the null is true, we can reject it or fail to reject it. If the null is false, we can reject it or fail to reject it. If the null is true and we reject it, that's a type 1 error. If the null is true and we fail to reject it, that's a good thing. Typically, it's not what we're looking to do, but it's kind of a good thing. If the null is false and we reject it, that's a good thing. That's essentially what we're trying to do with all these hypothesis tests is, reject a false null hypothesis. That, again, is referred to as the power. If the null is false and we fail to reject it, that's a type 2 error, and that's referred to, again, as beta. The power and beta are always going to add up to 100%. So just a little note here, if alpha is very small, you're more likely to make a type 2 error as you're making it harder to reject the null. So if that's a very, if you make alpha 1%, it's really hard to get a p-value less than 1% sometimes. So the smaller we make alpha, then we're making it harder to reject the null, essentially. Okay, so just a quick example, and then I'm out of here. So we have an example here where it says the Clean Air Standards require vehicle exhaust emissions do not exceed specific limits for various pollutants. Many states require that cars be tested annually to meet the standards. Suppose state regulators double check a random sample of cars that a suspect repair shop has been certified as okay. So they're going to revoke the shop's license if they find a significant evidence that the shop is certifying cars that don't meet the standards. So it says write a hypothesis for the situation. So notice I didn't use any numbers anywhere. There's no p-value, there's no p-hat. So as we progress through this unit, you're going to kind of notice that sometimes the ho-ha can just be written in words. So remember that the null means that nothing unusual is happening, that kind of everything is normal. So everything being normal in this case would just mean that the shop is meeting their standards, because that's what we expect from them. Whereas the alternate here would be if we started to see evidence that, hey, they're not meeting their standards. So that would be your alternate. So what you're going to have to do in this chapter is sort of describe what a type 1 error is in context, and then talk about what impact would that have on the situation. So it says, in this context, what would a type 1 error be? So remember, type 1 error is when the null is true, but we reject it. So if the null is true, the shop is meeting standards, but we reject that, that means that we're claiming that the shop didn't meet the standards, but it actually did. And so what would happen, it says they will revoke the shop's license if they find evidence that they're certifying cars that don't meet standards. So what would be a consequence of this is that they would revoke the shop's license, essentially. So a type 2 error is when the null is false, but we fail to reject it. So now that means that the shop is not meeting the standards, but we fail to reject that. So we think that they are meeting the standards. So what would we say? We would say that the shop met the standards, but it actually didn't. So what would be a consequence of that? The cars would continue to drive, and they just wouldn't meet the standards. And now they would sort of pollute the environment a bit more because they're not meeting the emission standards. The crazy thing about type 1 and type 2 errors is that there's never really a clear-cut answer as to which is worse. It really boils down to a matter of opinion. So in class we had a discussion about which of these situations is worse, and in most times you're going to have to put yourself in someone else's shoes for a moment. So I kind of did that for you in part D and E, where it says which type of error would the shop owner consider to be more serious to make, and that would be a type 1 error. Because when we make the type 1 error, they're revoking their license, and that's kind of a big deal as the shop owner. Whereas if you were an environmentalist, what would you consider a bit more serious? That would be a type 2 error, because now there's all these cars going out and polluting, and that's not good either. So just one last little thing before I go. We have this figure here that I was referring to as the power, beta, and alpha. You don't need to know how to calculate beta. You don't need to know how to calculate the power. All you really need to know, as I mentioned before, is that these things are connected. So imagine this as like a sliding glass door, that as I push this line to the left, alpha would get bigger and beta would get smaller, and the power would also get bigger. So the power, again, is the good thing. That's what we want. So we want the power to be big, but at the same time, if we make alpha too big, alpha, again, is the risk of making a type 1 error. And so if I make that too big, I'm going to be more likely to make a type 1 error, which is not a good thing. So again, that's alpha here. So the idea is to try to find a nice comfortable zone where this is kind of small, but this is still large enough that we're being able to reject the null when in fact it is false. Alrighty, so that's it for chapter 21. Thank you for watching. Have a lovely day.